My name's Lee, as you heard, and we're going to talk about some Mac times today. We're going to talk a little bit about Windows Mac times and how screwing them up and your interpretation of them is really not a good idea. And then we're going to talk about how Mac times can help you in your investigations. So this is me. Just recently started with SANS just a few months ago. This is great. I love working there. And while people enjoy going to the live events, I work on the on-demand side, so take some on-demand classes too. Yeah, by the way, the weight loss, the challenge for that is just a cover-up for the tapeworm infection. So let's start with Windows timestamps. And some of you are going to think, why are we talking about this? We already know about this. Well, there's a lot of people who think they know about this. So just pay attention, please. We've already locked the doors anyway. So Windows, most Windows systems use NTFS, as we know. And NTFS has the MFT. And in the MFT, each file and folder has got its own entry. In that entry, we'll expect to see two sets of timestamps, standard information attributes, and file name attributes, and we'll get to them in just a second. This is what I ripped off from Rob, the SANS poster, which everyone got a copy of, so you have no excuse. That one you have collecting dust in your drawer, you can throw away now and hang this one up on your wall. The best part of this, in my humble opinion, is this top corner. And here you'll see we have separated, we have the standard information attributes, and here we have 8 different scenarios where these items can and will change. Standard information attributes is typically what you'll see if you use off-the-shelf forensic software like Encase, Xways, FTK, they're those kinds of things. Seldom do they show the second set of dates and times, which is the file name attributes, which is a shame because, as you can see, obviously I've got these a bit blurred out now, but the standard information attributes and the file name attributes behave very differently, which can be a little bit confusing at times, but more often than not, this is going to be key to an investigation. So I want to share just a quick example with you, a case that I worked on recently. Some of you may be familiar with this type of scenario. We have a guy who works at a company, and he decides to leave the company, go to a competitor. Now, in this particular case, this guy didn't return the computer, his work computer, to his original company until 1 week after he left, which raised suspicion. So he sent this computer back. The original company had it forensically analyzed, and they found 2 things. The first thing is that the laptop had thousands of deleted work-related files on there, which is not a good start. The second thing that they found was that there was an external hard drive plugged in just 2 days before the laptop was returned. And through their analysis of the link files, the jump lists, and the MRUs, they were able to determine that there were quite a few files on this USB hard drive that shouldn't have been there. Files which had the same names and occasionally dates and times as those found on the deleted files found on the laptop. So they obviously weren't very happy, and I apologize for the language. So they weren't very happy about this. They got a lawyer involved, and they sent a request back to this guy, and they asked, we want this external hard drive. So the guy obliged, he sent it back, and further analysis was done. And the analyst found that, unfortunately, every single one of those deleted files from the laptop existed on this external hard drive. So this was a bit problematic. And the conclusion that they came to, after they spoke to their employees, was that this guy was not very technically adept, okay? He was not an everyday computer user. People said he could do his email, search the web, do some spreadsheet stuff, but that was it. So the most interesting thing about this external hard drive was not that all these files existed on there, but the timestamps associated with them. The created time was preserved at the time of copy. This event happened in December of last year. And if you refer back to your SANS poster, you'll see that file copying, or drag and drop, preserves only one timestamp, the last written time. But in this case, the last written time and the creation time are both preserved. So, given that this guy was not hugely into computing, and these dates and times have been preserved, the forensic analyst made a bit of a conclusion. And that is that in the week that he had this laptop, he took it into his new place of work. They had an IT person at this company load up some specialist copying software, copied those files onto the external hard drive, deleted those files, and then sent the laptop back. It's an interesting hypothesis. So they did, after they got the results of this analysis, they sent notice to the new company, and they basically added them to the list of defendants. Not happy at all with this scenario. So what did they do? Well, they went and hired a forensic analyst of their own, and that's where I come in. And so I took a look at the external hard drive to start with, and I saw pretty much the same thing as the other guy, that all the created and last written times were exactly as they were found on the deleted files. So potentially, yeah, I mean, you could say that specialist copying software was used here. But then, if it was, why are only half the times preserved? Why not the other half? Maybe some settings, maybe not. Well, let's have a look. So I went and looked at the file name attributes, and they were all exactly the same. And they all reflected the time that this transfer of data took place. So now I've got 8 MAC times to look at. So I went back to my trusty SANS poster. And knowing that the last written and the created time were preserved, but all of the other dates and times were updated, we could narrow this down potentially to a volume file move. Now, 2 questions from this. What's a volume file move, and why potentially? Well, volume file move, really, really straightforward and simple. It's, you have a window open over here for one drive, you right-click and select cut, you go over to another drive, you right-click and select paste. That's simple, it's a cut and paste, okay? Now, if that's the case, then all this stuff about the specialist copying software is all in the heads. And that's what we want to prove. Now, why potentially? Well, we've only looked at half of the evidence. We haven't looked at the external hard drive. So let's take a look at the laptop. Well, if this is a cut and paste, the key thing that we're going to look at here is we want to see that a cut is going to delete the files at the exact same time that they're copied to the external hard drive. So we want to find out when those files were deleted. Now, here's the rub, is that file deletion, and people always say this isn't true, file deletion is not recorded in the MFT. Okay? The time that the file is deleted, you will not find from the MAC times. And I get people saying, anyway, I posted this the other day, and I got like a flood of emails. It's not true, it's not true. It's true, okay? Just deal with it. So we want to look at somewhere where we're going to get these file deletion times from. So we're stepping out of the MFT for just a moment, and we're going to look at the USN journal. And so here, we've got all the stuff from the file name attributes, all the dates and times, and we want to make sure that for each file, each and every single one of these thousands of files, that when it appeared on the USB hard drive is the exact same time that it was deleted from the laptop. And because I'm standing up here talking about this, you probably already figured out, they matched up perfectly. So we now went from our our hunch that this was a cut and paste to it was definitely a cut and paste. So we went and we also looked for evidence of the specialist copying software being used, and as you may well have guessed, there was nothing. So we went back to the court. We said, look, this is the evidence we have. The court agreed. The opposition was forced to concede, and they removed my client from the list of defendants. So they were very, very happy about this. So the one thing that I just want to touch on quickly is that frequently, when we do investigations, we find one thing, and it sets us on course. Now, good investigators will alter course when they see more evidence. I'm not going to say bad investigators, because it happens to everyone, but probably less experienced investigators will not course correct when they see evidence which contradicts what they believe. It's so important that we let the evidence speak for itself and that we just become the mouthpiece. We can't let our own agendas affect what we put in our reports. So that's the end of that. That's the Windows piece wrapped up. It's so vital that we understand how timestamps work and how they're manipulated, because I spoke to another very experienced forensic investigator after I did this case and explained what happened. And he's like, you know, I don't think I would have seen that. So use that poster. It's awesome. So that leads us on to Mac times. And Mac OS uses HFS+, at least it does for now. It's going to change for SSD drives very shortly. But HFS+ has something called the catalog, which is like the MFT for NTFS. Once again, each file and folder has its own entry in that catalog. And for each file and folder entry, there are a set of Mac times. There's created, there's written, there's accessed, and there's record change. And these are all stored in HFS+ 32-bit values. Then Apple kind of went off the rails a little bit, and they added another timestamp, and this is called the added date. And when you look at these first four in the catalog, they're all nicely together in a nice little section, one after the other, all nice and neat. But then right at the end of the catalog record for a file, crammed in at the very end, is something called the added date. And this added date is not even in the same format as the others. This is crammed in as a Unix 32-bit value. Now, for a company that's so hung up on aesthetics and design, this is really crap. So, I love Apple, but this is stupid. So, yeah, I mean, for obvious reasons, this is going to be referred to as the Jon Snow value. And the whole reason that I went through all this testing and figure this out is because I wanted to recreate the same kind of thing that we see on the Windows SANS forensic poster for times and do the same thing for Mac. So I'm going to run through just a few examples because I'm going to go over time anyway. So we'll start with file creation. As you can see, for file creation, the 4 regular timestamps are updated, but that last added date is not populated at the time of file creation. You know nothing, Jon Snow. File modification, the creation time doesn't change, the added time doesn't change, but the other 3 do. And then we get onto something a bit more complicated. File duplication. File duplication in Mac OS can be done in one of 2 ways. You can right-click on a file, select copy, right-click, and select paste, but that's a huge 4 mouse clicks. And that's just not Apple's way. So you can right-click on a file and select duplicate, and the same thing will happen. A new file will appear. So only 2 mouse clicks. That's right, Microsoft, suck it. I love Microsoft, really honest. But here's the problem. Our case that we talked about earlier on with the Windows machine, if it had been a Mac system, we run into a problem because the volume file move and file duplication change the exact same timestamps. So it means that you have to dig in really, really deep to try and figure out whether it was actually a move or file duplication that had taken place. So that's the finished chart. This will go up on the SANS website after the summit is over, so don't worry about getting a picture right now. And then what happens whenever you start to introduce other file systems? Well, this is where it gets really fun. So we'll start with FAT because Mac OS has got built-in support for read and write to and from FAT. So with FAT, whenever you create a file, whenever you move a file, and bearing in mind that copy and moving are the same thing, created, last written, are inherited from the original, and access date is updated to the time, or updated to the date that the copy was made. What about the other way around? Well, I mean, it's pretty much the same, except that there's just more values. So, created, modified, once again, inherited, everything else updated to the time of copy. Now, there is a bit of an issue here, is that if you've got a file, picture.jpg, and you copy that from your Mac onto a USB, which is formatted as FAT, and then you then take that drive, plug it in somewhere else, and you access that file, that access time gets updated, which means you no longer know when that file was put on that drive because that access date was the only thing telling you when that file was copied. Well, there's some good news. And you may have seen this if you operate between Windows and Mac quite frequently, is that whenever you copy a file on from HFS Plus to a FAT file system, not only do you get the file that you copied, but you also get a ._ file which has almost the exact same name. Now that file contains various pieces of metadata that you can take a look at, but the interesting thing is that because that's not being copied from anywhere, that's a brand new file being created on the fly, that the created time of that file will equate to the created, well, within a few seconds, of the created time of the original file that was copied onto the drive. So, great stuff to know. What about NTFS? Well, macOS has got native read from NTFS, so let's start with that. It's exactly the same as with FAT. Okay? Created, modified, preserved, everything else updated. And then what about going to NTFS? Well, you can do this in one of three ways. The first way is that, this may come as a surprise to a lot of people, is that macOS actually has a native NTFS driver built into the operating system. You can enable this by going into a certain plist and adding a value, and it will almost guarantee the screwing up of anything you have on an NTFS drive. I would advise heavily against using that. The second thing you can do is that you can use the open source tools which are out there, but here's the thing, you've got to install like 3 or 4 different things, and then as soon as one of those updates, or the operating system updates, then everything breaks and you have to start again. So it can be time-consuming. The third option, which is the one I choose, because I'm lazy, is using a paid product to do that. And Tuxera, Paragon, things of that nature. I use Tuxera. So you use those, you transfer a file from HFS Plus to NTFS, and this is what you expect to see. Same thing as you would for a volume file move on Windows. Created, last written, preserved, everything else is updated. Note, if you copy to NTFS using something like Tuxera or Paragon or one of the open source alternatives, you do not get the ._ files, okay? The reason is because the metadata contained within those will be natively adopted by NTFS. So just watch out for that. Another complication, this one really needs to be addressed, is that we talk about file access. Now, as we're aware, in Windows, this was pretty much turned off from Windows Vista onwards. Still active on Mac OS, and so you may think this is great, I know when the user last opened this file. No, you don't, not from this value. This value can be updated a number of different ways. One is being indexed by Spotlight. Another one is a user right-clicks on the file and says get info. That will update this too. But there's also other issues that I'm going to walk you through now. And I'm sorry this might be a little bit small for people to see, but you can see, if you're close enough, you can see here that I've run a stat command on a specific file. And on this file, we see that this file was last accessed on October 17th, okay? But in the GUI is reporting that it was last opened on October 12th. It doesn't make much sense. So I closed the file, opened it again, closed it again, ran stat again, the exact same thing. The access time had not updated. But the GUI updated to the date and time that I had opened the file. So this left me a bit confused. I know this is not in the catalog anywhere. I mean, I looked hard for this. So I ran the mdls command. And mdls pulls in all the metadata for a given file. And I found some really cool stuff, more than I expected to see. The first thing is this KMD item last used date, which corresponds exactly to the last opened date that we saw in the GUI. But more than that, we've got these other two cool things down at the bottom. The first one is this KMD item use count, which allegedly gives the number of times the file has been opened. The problem is this increments by 1 or 2. It just depends, and I have not figured out what that depends on yet, but we'll figure it out. But the other cool thing is just KMD item use dates. This is an array, okay? So if you have a user that says, I didn't know about that file, I don't know how it got there, it was nothing to do with me, well, why have you opened it several times? Now, unfortunately, this only resolves to the date. As you can see, the time is kind of blanked out, but still very, very useful for us to know. And then, as I was looking at this, I found some other cool stuff. With KMD item user modified date. This one, also very, very cool. Another array, and this will tell you all of the times that the file was saved. Now, I haven't quite maxed out how large this array is yet, but not only do you get the date and time these files were opened, but you also get this other handy little array down at the bottom, which tells you which user was responsible too. So once again, very, very handy. I had no idea about that file. I've never touched it before. Well, you've opened it this day, and then you've saved it this time and this time and this time. Are you sure you didn't know about this? I think they changed their story pretty quickly. And then finally, we come to something which puzzled me for the longest time. We have an array for created date. Why do you need an array for creation? You create a file once. Another one of those stupid Apple things. Oh, all right. Well, anyway, and this, I didn't figure this out. I'll be honest. This was Nicole, who spoke earlier today, helped me with this by doing some of her independent testing on this. I don't know why they do this, but Apple. So, in order to get this to work, like let's say you have a file sitting on your desktop. You open and save that file, this doesn't update. You save as over the top of that same file, this doesn't update. If you have another file that's on another drive or in another folder, you open that and then save over the top of the file on your desktop, this gets updated. Why do you want to track that? I don't know. Apple. So, yeah, thank you, Nicole, for helping me out with that. Now, it's just something to bear in mind here, is that depending on the file type, the three arrays that we've looked at can behave differently, okay? So if you have like a native Apple app that you're using, like Text Edit or Preview or something like that, you close those and it automatically saves stuff. You will see that the modified time will be updated every single time you close it out. If you're using Microsoft Office and you save a file, this does not get updated. If you do save as and save over your existing file, this does get updated. So that might change with future versions. We'll have to wait and see. But yeah, and that's pretty much everything that I've got for you today. Just to recap, just want to make sure that everyone knows you've got to know your Windows times. If you don't know your Windows times, you're going to get caught out. The accessed on Mac OS does not necessarily mean user accessed, so bear that in mind too. And then finally, do not twist the facts to fit your story. Just let the evidence speak for itself.